In this video, the one-sample t-test is going to be introduced. The one-sample t-test is used in order to compare the mean score of the sample with a target mean that is considered as a population mean, mu. Therefore, the question is whether the mean score obtained from the sample is statistically different from the mu or not. Let's consider this example. I measured the height size of 26 students in my class. The average height was 1.69 m, and the standard deviation of this sample was 8.39. Don't get a panic. I measured both male and female students. We already know that the standard error, in short SE, indicates the range the sample mean would vary. Therefore, the sample mean X bar subtracted by the population mean divided through the SE would indicate a sort of a ratio regarding the mean variability. Just recall the procedure of calculating the z-score from the previous lecture. The z-score indicates the relative scale of every single score with regard to the entire sample data. Similarly, the t-score indicates the relative scale of your sample mean with regard to the population mean. That is the basic concept, and that's the only thing you need to remember. In the one-sample t-test, the t-value is calculated through this formula. It is too simple to forget. However, you don't need to memorize this. The only thing to remember is always when to use what statistic. In the one-sample t-test, we basically assume the same variance between the sample and the population. Also, we assume the distribution of the sample is fitting to the normal distribution. Often, we skip the test to check the normality of the data, but basically it is assumed. And the degree of freedom, df, is obtained by subtracting 1 from the sample size. Then let's copy this table to Excel. Here you go with the Excel sheet. I copied the table here and pasted it. Because I marked the centimeters, I remove here centimeter unit in order to consider the numbers as numbers, not a part of a text. Let me see whether they are considered as numbers. Okay. So then let's calculate the standard error in this cell. So the standard error is C4, the standard deviation, divided through the square root 26. Alright, the standard deviation is almost 1.65. So the t-value is the mean subtracted by the population mean divided through the standard error. Alright, so the t-value here is 1.29. And let's see what this t-score has what kind of implication in t-distribution. Remember that we have degree of freedom of 25. So 26 subtracted by 1, 25. Let's go to distribution, t-test. And when degree of freedom is 25, then in order to say that the sample mean is statistically different from population mean, the t-value should be at least 2.06. Remember that our t-value was 1.29? So our t-value is positioned somewhere here. Therefore, we cannot say, or we cannot conclude that our sample mean is statistically different from the population mean. Therefore, although we have observed that our students are bigger than population, and for that moment I was very happy, but the statistics yielded that this difference is just observed data and statistically not significant. And in addition, of course, we can perform the one sample t-test in SPSS. Let's say we have given the height data of 26 people like this. So 26 people had the height data in such a way, and click analysis and comparison means one sample t-test, and you put the data to analyze, and here is the value of the mean population. And where this 166.91 coming from? This is the website of Science Korea, and here you can get for free all measurements of Korean population. Of course, this website did not measure actually the real entire population of Korean people, which is more than 50 million people. But because they had a large enough size, so we can consider that the data provided on this website is almost identical or equal to the population mean. So, alright. So t value is obtained like this, and we had a degree of freedom 25, and here the p value is far bigger than 0.05, so the mean difference is not statistically significant, so it's not different.